Hello, Algebra 2 students, and welcome back. We are beginning Chapter 10, which is the last chapter in the book. Can you believe it? In this chapter, we're going to develop the idea of a function. But before we can talk about a function, we need to define a relation. So here's the definition of a relation. It's really very, very simple. It's just a set of ordered pairs. And it can be defined either in terms of a graph, a set of ordered pairs, or a graph which illustrates a bunch of ordered pairs. So here's some examples. So here are just two very, very simple examples. Relation R1 has simply 3 ordered pairs, and relation R2 has 4 ordered pairs. Contrast that with the idea of a graph of a relation. Well, I'll just do that like this. And R3 would simply be all the ordered pairs that are indicated by that graph. Remember, every point on a graph is an ordered pair. So this graph illustrates an infinite set of ordered pairs. So those are two different ways of describing a relation. One of the things that we talk about when we talk about a relation is the domain and the range. And the domain is all x values, and the range is all y values. So that if we're talking about R1, the domain is just the x values, which is 1, 5, and 3/5. That's it. If we're talking about R2, the domain is 5, 7, we only count 5 once, and 8. Okay, if we're talking about the range for R1, it's 3, 8, and pi. And for R2, the range will be 2, we only count it once, 4, and 6/5. Okay, that's domain and range. Now, I said we had to talk about a relation before we talked about a function. And the reason is that a function is a special relation that satisfies a certain condition. And let's write that down. So the point here is that a function is a relation in which each input, usually an x value, can be paired with only one output value, which is usually a y. Now, based upon this information, if you go back and you look at it, R1 is a function, but R2 is not a function, and the reason is that it had 2 points. One of them was 5, 2, and the other was 5, 4, and in this case what we have is the same input is paired with different output values, and that can't be. For every input value, you can have only one y value or output. So that's the big deal when a relation is not a function. Another way to see that a relation is not a function is by looking at the graph. And let's suppose the graph looks like this. Well, what we can do here is draw a vertical line. And if a vertical line hits the graph, this is called the vertical line test. If a vertical line hits the graph in more than one place, what that means is there's more than one y value that goes with just an x value. Remember, the equation of a vertical line is something like x equals some number. Let's say x equals 2. So this point right here might be 2 minus 1, and this point up here might be 2, 3. And so this can't be a function, because the same x value, namely 2, is being paired with, or matched up with, two different y values. So the vertical line test says if a vertical line hits a graph more than once, then it is not a function. So a very easy visual way to see when a graph is a function or not. Now, functions are usually given names like f and g and h. So here are some examples of the way we can write functions. We'll talk about a function f of x is equal to 3x minus 5. Now, instead of f of x, we could write y. F of x is the same as y. And all this is saying is take whatever comes in and multiply it by 3 and subtract 5. We can talk about a function g of x, which is x squared, quadratic function. And how about h of x, which is equal to the square root of 3 minus x minus 2. Now, when you have functions written like this, it's nice because we can talk about f or g or h, and we know what, in each case, the different function does. So, for example, I might say something like, what is f of 1? And what that means is, when x is 1, what is y? So this is like my x value. Well, f of 1, you should be able to see, is minus 2. So what that means is, on the graph, we have the point 1 minus 2. How about this? What's g of minus 3? Right, it's going to be 9. And that means the point minus 3, 9 is on the graph of g. And finally, how about h? And let's say h of, I think minus 6 will give you an interesting one. H of minus 6, 3 minus a minus 6 is 3 plus 6. That's 9. The square root of 9 is 3. 3 minus 2 is 1. So on the graph of h is the point minus 6, 1. So let's make just graphs of f and g and h, just so that we can see what they look like. So here are the graphs of f, a straight line, g, parabola, and h, a square root function. And in each case, we'll write down what the domain and range are. So for f, the domain is all reals, anything. We usually write that in that kind of notation. The same thing with the range. For g, the domain, again, can be anything, but the range, the possible y values, are just y greater than or equal to 0. And h is probably the most interesting one. For h, the domain is x has to be less than or equal to 3, otherwise we'd be taking the square root of a negative number. And if you look at the way the picture works out, the range is y greater than or equal to minus 2. So that's something that you should be able to look at and understand. Okay, let's hold on, and we'll keep going. So let's talk about looking at the graph of a function and trying to determine, a graph of a relation and trying to determine if they're a function, and we'll be using the vertical line test. Okay, so here are 3 graphs of relations. When I draw a vertical line anywhere on this function, it's always going to hit only once. So this is a function. It's very easy to see that if I draw a vertical line anywhere over there, it's going to hit the graph more than once. So this is not a function. And similarly, this one looks like a circle, and it's very easy to draw a line which hits more than once. So this also is not a function. So the last 2 are relations because they are ordered pairs. They're sets of ordered pairs, a set of ordered pairs, but they are not a function. All right, so there's the vertical line test helping us out. Okay, so check this out. We're asked to find the domain of a function which looks like a rational function. And before we can answer that question, we have to write the bottom at least, in factored form. So we'll do that. So here's f in factored form. And so now the question is, what's the domain? Well, the way to answer that question is, in all cases, is begin by saying, well, is there anything that x can't be? We saw in the previous example, when you have a square root, you can't have any x values that make the square root value negative. Similarly, in a case like this, where we have a rational function and we have a denominator, you should be aware that the denominator can't be 0. So therefore, the domain is all reals except the values of x that make the bottom 0, which are x is equal to 5 and x is equal to minus 3. And if you remember, that's where we have vertical asymptotes. And a rational function is not defined when we have a vertical asymptote. So there we go. That's a lot of information about functions and relations. And you need to practice a little bit. You need to watch this carefully, and you need to do your homework problems. Okay, see you the next time. Bye-bye.